This is a mock-up control panel for Itoh-Denki transfer using individual standalone Itoh-Denki drives controlled individually through this Automation Direct Click PLC with one I/O card, 8 in, 6 out DC power supply. And it is standalone, currently based on just a photo I input with the ability to tell it at what point down 32 inches to begin the transfer. And then the transfer moves 90 degrees. It can move bi-directional. Right now I'm just doing it one direction. I'm using a test box. This sensor that's looking for the box is right there. I just blocked it. It is currently going to come this way and then this way in the transfer. So that is the features of it, function of it. It is able to do it in a scan time of under 1 millisecond, right at 1 millisecond, which helps preserve the up transfer. You can tell that it is not hitting the mechanical stop on the up motor, because if it does hit that, it will eventually fail because it's going to damage that mechanical stop on the mechanism, making the motor bring it up. As previously mentioned, this is the Click Plus processor with combination card, 8 input, 6 output, DC in, DC out. It can be set up, and it is currently set up as a Ethernet remote I/O. However, I'm not using Ethernet remote right now. I actually have written some code in the Click software, and that code allows, it's pretty cool, but you can set this code up to function, or rather set the PLC up to function as an Ethernet IP slave. It gives you the setup for Ethernet. So then in a master scanner, you can tell this scanner to look out there and find I'll find it in a minute. was already there, wasn't I? Yeah. System configuration. So this processor is got an Ethernet port. And then by name, I have it set up as a click transfer. The COM setup, so that is the address for this unit. The scanner then can be looking at this unit as remote I/O, and you can force it off and on, force it to energize the transfer functionality remotely, but it still operates that transfer on the scan time of the PLC. Right there's the scan time. It's actually under 1 millisecond. Right at or under 1 millisecond. These are the inputs, X numbers, and outputs are the Y numbers. This was a previous setup that I just use it as a cheat sheet in the logic here. And then this is a simple code. It's just simplified. Goes down from rung 7 to rung 22. So it's not a lot of functionality to make it operate. But if you do this as a remote and all the code is in the PLC with the scanner, you potentially run the risk of scanning it slower than the speed the motor is using to get the transfer to pop up, which would drive it into the hard stop of that motor. And repeatedly doing that will cause damage to that mechanism. So this is one way to get by it. If your scanner can scan it well under 20 milliseconds, then you can write all this code in the scanner PLC. It's all simplified, and it can get more elaborate as well. Currently I'm tracking it with a clock pulse, 100 millisecond clock pulse. There's my 100 millisecond clock pulse, which is not an inch, but it can be close. I could create and make that to be more like an inch by a new number of like 118 milliseconds or 120 milliseconds. But anyway, that's I'm just using shift register to move the numbers down through there. So here's the tracking data. Starts at 101, tracks to 132. It's 32 inches long on that transfer. So you can see when that turns on and goes ons down through there, it's just clocking through, and the back of the box goes through there and turns it off. And in the logic currently I just have the number when C110 goes on, triggers the transfer. When it goes off, in the transfer. Pretty much it. Thanks for watching.